What if 10 small devices could power an entire building without a single drop of fuel or connection to the grid? High voltage. What if this wasn't a theory, but something happening right now? Today, we're diving deep into an extraordinary experiment, one that could redefine everything we know about electricity. This is what happened when 10 Maxwell MSED devices were linked together, and the results were beyond imagination. Rocket. For years, Maxwell Chikumbutso's name has hovered between genius and myth. The Zimbabwean inventor who introduced the world to the MSED, microsonic energy device, a box said to capture ambient electromagnetic waves and convert them into usable energy. Skeptics called it impossible. Supporters called it revolutionary. But no one could ignore one truth. Maxwell's technology works in silence, without fuel and without emissions. The world watched as his early prototypes powered lights, small vehicles, and even drones, all without plugging into anything. But one question remained. What happens if multiple MSED units are connected together? Inside a modest test facility, 10 MSED units were lined up, each one no bigger than a car battery, yet each humming with silent potential. Engineers connected them in a parallel configuration. Their goal was simple: amplify the energy output while maintaining stability. As the final link was made, the monitors began to flicker. Readings started to climb, first by tens, then hundreds, then thousands of watts. But then, something unexpected happened. Instead of plateauing as conventional systems do, the power curve continued to rise, smoothly, consistently, and seemingly without limit. The devices appeared to be resonating with one another, creating a kind of energy feedback harmony that engineers hadn't anticipated. It wasn't chaotic. It was controlled, synchronized, alive. At the height of the test, the combined output reached a level powerful enough to run an entire home, continuously. No overheating, no loss, no decay in current. One of the lead engineers described it as the closest thing to perpetual energy we've ever witnessed. The room fell silent, except for the quiet hum of the 10 devices working together, generating pure, stable power from thin air. What they had built wasn't just a test setup. It was a proof of concept that energy could be drawn, multiplied, and sustained without traditional fuel sources. If this breakthrough can be scaled, it could mark the end of energy scarcity as we know it. No more fuel imports, no more blackouts, and no more dependence on unstable grids. Imagine entire towns powered by self-sustaining microgrids, electric vehicles that never need charging stations, homes and factories running indefinitely, powered by invisible waves of ambient energy surrounding us every second. It sounds like science fiction, but for the first time, it might not be. Despite the awe-inspiring success, many questions remain unanswered. How exactly does the resonance between devices amplify the output? Can the system remain stable at a larger scale? And perhaps most importantly, who will control this technology if it becomes mainstream? As Maxwell's team continues to refine their designs, governments and corporations are quietly taking notice. The energy revolution may no longer be coming. It may already be here. 10 devices, one experiment, infinite possibilities. Maxwell's MSED network could change the course of human history or challenge the very foundations of how we think about power itself. Because sometimes the most powerful energy source isn't found underground. It's been around us all along. Battery. 10 Maxwell MSED devices linked together. The results are beyond imagination. As the testing continued, the engineers began noticing subtle but intriguing patterns. The electromagnetic fields around the linked MSED devices seemed to move in harmony, forming a rhythmic pulse that was almost musical. Sensors detected gentle oscillations, not random noise, but repeating frequency that suggested the devices were communicating in some way. This interaction wasn't something the team had predicted. Each MSED was designed to work independently, harvesting ambient energy from the environment. But when connected, they began to operate as if they were part of a single living system, amplifying each other's capabilities and maintaining perfect balance. It was as if the devices had found a way to share energy information, creating what one scientist described as a cooperative resonance network. The experiment was extended over several days. The The engineers wanted to test the limits. How long could the system sustain itself without interruption? Hour after hour, the output remained steady. There were no signs of overheating, no instability, and no loss of efficiency. The readings remained remarkably consistent, defying traditional expectations of energy systems that always experience some degree of loss over time. To verify the results, independent observers were invited to monitor the data. They used separate instruments, recalibrated sensors, and introduced variables such as changes in temperature and electromagnetic interference. Yet, the results stayed the same: stable power output, clear data integrity, and a flawless performance across all 10 devices. As the word spread, researchers from other institutions expressed deep interest in replicating the phenomenon. The potential applications were almost endless. A cluster of MSED devices could power isolated villages, remote research stations, or even emergency medical facilities where traditional infrastructure was unavailable. The idea of energy independence, once a distant dream, suddenly felt tangible. Behind the scenes, however, Maxwell's team maintained a cautious approach. They understood the magnitude of what they were witnessing, but also the importance of ensuring scientific transparency and safety. Detailed logs were compiled, and every phase of the experiment was documented meticulously. The goal was not to rush to commercial use, but to understand why and how these devices interacted in such an extraordinary way. Some theorists began to propose new models of energy resonance. They speculated that the MSED network might be tapping into naturally occurring electromagnetic harmonics, frequencies that exist all around us but remain in use by conventional technologies. By synchronizing with these harmonics, the devices could effectively multiply available energy without violating any known physical laws. It was an elegant concept, and one that hinted at a deeper understanding of the world's hidden energy layers. As more data was analyzed, one conclusion became increasingly clear. The MSED network wasn't just generating energy, it was demonstrating a new way of interacting with the electromagnetic environment itself. The implications of that discovery went far beyond power generation. It opened doors to potential advances in communication systems, propulsion, and even environmental balancing technologies. Representatives from several countries reached out, expressing interest in observing the technology firsthand. They wanted to understand how something so compact and elegantly designed could perform with such balance and reliability. The team welcomed the visitors with openness and humility, sharing their data and demonstrating the operation of the network without embellishment. The guests left deeply impressed, not only by the results, but also by the peaceful atmosphere surrounding the work. Soon, collaborative discussions began to take shape. Research groups proposed joint studies, universities offered facilities for extended testing, and clean energy advocates expressed a desire to see the MSED system integrated into global sustainability initiatives. What had started as a quiet experiment in a modest workshop was now becoming part of a broader dialogue about the future of energy. Maxwell's team continued to focus on refinement. They began designing newer versions of the MSED units, smaller, lighter, and easier to synchronize. Each device was equipped with improved sensors and adaptive circuits that allowed it to respond intelligently to changes in environmental energy fields. The upgrades made the network even more responsive and stable, and the team often marveled at how natural and seamless the flow of energy had become. In time, the project expanded beyond the laboratory. Several pilot sites were established in rural areas where access to electricity had long been a challenge. The installation process was simple, and within hours, homes that had once relied on candles and small generators were illuminated by clean, steady light. The air was quiet. The nights felt calmer, and the people spoke of how life seemed to move at a gentler rhythm. Local communities began to take part in maintaining the systems, guided by the engineers who trained them patiently. This partnership built a sense of ownership and pride, the feeling that they were part of something much greater than themselves. For many, it wasn't just about technology. It was about connection, cooperation, and shared hope. Meanwhile, academic institutions continued to study the deeper mechanics behind the MSED resonance effect. Some theorists suggested that the network might be interacting with naturally occurring electromagnetic fields that extend far beyond local space, perhaps linking into global harmonics that have always existed but remain unnoticed. These discussions encouraged new lines of inquiry in both physics and environmental science, as scholars sought to understand how energy and nature could coexist in such quiet symmetry. As data accumulated, a new realization began to form. The MSED network wasn't merely a tool for power generation. It was a model of harmony, a physical demonstration that systems could operate in unity without depletion or imbalance. The principle seemed almost philosophical in nature, reflecting how progress could emerge from cooperation rather than competition. Maxwell often described this idea with gentle conviction. He would say, "When we align with nature's rhythm, energy becomes effortless." Those who worked with him found inspiration in his calm perspective. He never claimed mastery over the discovery. He viewed himself as a student of the natural world, learning from its quiet wisdom. In the month that followed, more nations began to explore potential partnerships. Some proposed community-scale installations, while others envisioned using the technology for emergency relief operations or scientific outposts in remote regions. The conversations were filled with optimism and a shared sense of purpose, a recognition that the world might be entering a new chapter of energy understanding. Through it all, the original 10 devices continued to operate at the research facility, unchanged and steady. Their soft hum had become a symbol of the journey, a reminder of where it all began. Late at night, when the lights dimmed and the lab grew quiet, that faint, rhythmic vibration could still be heard, echoing the promise of future where energy flowed freely, gently, and endlessly in harmony with the world around it. As the months unfolded, the quiet influence of Maxwell's discovery began to ripple across continents. News of the MSED technology reached conferences, research summits, and policy discussions around the world. Yet, unlike the rapid commercialization that often follows major inventions, this movement grew slowly, thoughtfully, and with deep respect for principles on which it was founded. Governments approached the project not with urgency, but with curiosity. Environmental organizations praised its potential to reduce dependency on fossil fuels and bring sustainable power to communities long left in darkness. Meanwhile, scientists from different fields began collaborating in a way rarely seen. Physicists, environmentalists, engineers, and philosophers united by a shared vision of balance between humanity and the natural world. Back at the original facility, the team gathered one evening to reflect on their journey. The 10 MSED devices, still quietly operating, filled the room with a soft, familiar hum. It was difficult to believe that these small, silent units had started something so profound. Around them were notebooks filled with data, sketches, and observations, traces of endless nights spent in exploration and discovery. Maxwell stood quietly near the row of devices, his expression calm yet thoughtful. He knew that the work ahead would continue for generations, refining, expanding, and understanding what this technology truly meant for humanity. But at that moment, he felt a deep sense of peace. The experiment had fulfilled its purpose, to show that energy could be created in harmony, without destruction or depletion. The team watched as the readings remained perfectly stable, the flow of energy unwavering. There was no noise, no smoke, no vibration, only quiet light filling the space. It was a vision of what the future could be, clean, balanced, and deeply connected to the rhythm of the earth itself. Outside, the night was still. The stars shimmered above the horizon, their silent glow mirrored by the steady light of the MSED devices below. It was as if the universe itself was watching, acknowledging the quiet union of science and nature taking form on this small patch of land. In the distance, the soft breeze carried with a promise that every discovery born from curiosity and respect has the power to reshape the world in gentle but unforgettable ways. And so, the story of the 10 MSED devices came to rest, not as an ending, but as a beginning that continues to unfold wherever people seek harmony between innovation and the living world. The hum of the devices remained, soft and steady, a whisper of energy, a symbol of hope, and a quiet reminder that sometimes the greatest revolutions begin not with noise, but with silence.